Okay, welcome back to another one of these kind of grade 5 to grade 9 full walkthroughs for completing the square this time. So once again, the questions are in the description if you'd like to follow along. If you want to try these for yourself first or try them after the video, you're more than welcome to. But I want to go through everything you need to know for completing the square, from the very beginner questions, which is still a pretty tricky topic, but from the beginning all the way to the end, and explain exactly how I approach them and explain how you know when to do it and what kind of questions they can ask you. So I think the best way to learn completing the square is just by doing initially, okay? And completing the square is useful for two reasons. The first one is if you look at this part B, it gives you the turning points of quadratic graphs, okay? Cool. And the second reason we're going to come on to a bit later. But in general, if you have a quadratic that looks like this, x squared plus bx plus c, then you can write it in this form by simply doing this. You get x plus then half of b squared minus half of b squared plus c on the end. That's it, okay? A few things to note though is that there is no value in front of the x squared, okay? And we'll come on to examples where there is a value in front of x squared a bit later on. So for this question here, it says write x squared minus 6x plus 1 in this form. So what we're going to do is, just looking at our equation, b is the number in front of x, and that includes the sign, so in this case minus 6. So we're going to put the x, and then what is b divided by 2? Well, it's minus 6 divided by 2, which is minus 3, so I'm just going to put that there. Squared, then minus 3 squared. Again, make sure you use brackets. The most important thing about this term here in the middle, the minus b part, is it's always going to be negative no matter what, okay? And then we're going to have the plus c on the end, plus 1. So then we just do x minus 3 squared. Then we have minus 3 squared, which is 9. So minus of that is minus 9 plus 1. So finally we have x minus 3 squared minus 8. And that is all you need to do. Now for the turning points, so what they mean by a turning point, that's probably a good place to start, is when you have a quadratic, right? It's a happy face or a sad face, right? Like a u or an n. And so let's say if we have a u here, the turning point is where the graph turns. Shocking, right? But essentially it's either the lowest value, or if you have a sad face, it's the very peak up here, okay? And completing the square will give you straight away what that turning point is. So in this case, can you see that this is the minimum value? So if I wanted to make this as small as humanly possible, what is the smallest thing that this thing can be here, this squared? Well, if it's negative, it squares and becomes positive, so that's big. And if it's positive, it squares and becomes even more positive, which is big. So the smallest this thing here can be is 0. Because if it's less than 0, it squares and becomes bigger than 0. And if it's bigger than 0, it squares and becomes bigger than 0. So in other words, my x coordinate is however I can make this bracket equal to 0. This is always the case. And if you have a look, it will just be x is plus 3. Okay? So actually let's do it down here. Okay. And if I sub in x is 0, then I'm just left with minus 8. So I get 0 minus 8, which is minus 8. That would be your turning point. So I've explained the logic behind it, the maths behind it, but how can I remember if I don't really care about the maths? Well, all you do is you take this number and flip the sign. So if it's positive, it becomes negative, negative becomes positive, and you just write this exact same thing. So I took minus 3, flipped the sign, it's 3. Took the minus 8, kept it the same. Always the same. Okay. Let's just do another one as practice, okay? Again, my b in this case is 10. So we're left with x plus 10 over 2 is 5 squared minus 5 squared plus 2. So we're left with x plus 5 squared minus 25 plus 2. So we're left with x plus 5 squared minus 23. Easy as, right? Not too bad. And if you notice again, it's negative for this value here, okay? Technically this thing at the end can be overall positive if c is bigger than b squared, right? So again, what are the turning points? So take a second to think. Again, there are two ways to do it. I take this number and I change the sign, minus 5. I take this number and I put the exact same thing in, 23. That's it, minus 23. Okay? So you have to do Super, super lightweight in this case, okay? Okay, what if there's a 2 in front? Well, this is where things get slightly more tricky. If there's a 2 in front, there's a few different ways you can do this. My personal recommendation is to factorize out whatever's in front of the 2, okay? So I'm going to put 2 x squared minus 6x, and I'm going to leave the 23 at the end. Because if you remember, the 23, all it does is it adds at the end. So I'm going to leave it out. Now I'm going to do completing the square just on the stuff inside the bracket. So we're left with 2, right? What's b in this case? It's minus 6. So x minus 3, because half of minus 6, squared, minus 3 squared, and then plus 23. Okay, now let's start simplifying this a little bit. I use these kind of square brackets that you can see. They're called staple brackets because it helps me differentiate which set of brackets I'm actually using, right? So I have the curved ones, then staple ones, okay? So I know that 2 is timesing everything inside the staple brackets. When you use different levels of curved ones, it can get a bit confusing. Minus 3 squared is 9. Minus of that gives me minus 9 plus 23. Now all I do is expand those staple brackets. So 2 times x minus 3 squared is just 2 times x minus 3 squared. Minus 18 plus 23. And lastly we get 2 x minus 3 squared plus 5. Okay? Now that's our answer. 3 marks, so we get a bonus mark. So if you noticed in the previous questions they're all 2 marks. We get a bonus mark just because they put a 2 outside. Not really any extra work, right? It's not that bad. So now the question is, what about the turning points? Do I have to half anything? Ignore it. Okay? Exact same thing. All I do is, since I'm making this 0, it doesn't matter if I'm doing 2 times 0 or 0 times 0 or 1 times 0, right? So you do the same thing. You take the minus 3 and you flip the sign to make it positive 3. You take the number on the end and you keep it exactly the same. Those are your turning points. Because again, when we're if you want to know the mathematical reason, when we're working out the turning point, we make this bracket equal to 0. So we have 2 times 0 plus 5. So it doesn't get affected. So super, super easy. Okay. By the way, these turning point parts, they're all worth 1 mark. Okay? Okay, so we've got the same thing again. Now, we can actually do something a bit more interesting in this one. We could factorize 3 out of the whole thing, because all 3 of these things are divisible by 3. But I don't think it's really going to help us, so I'm not going to bother doing it. So, and we have x squared minus 10x plus 63. Again, if you put 63 inside the bracket, well, you'd put 21 inside the bracket if you factorize out of 3. You get the same answer, it doesn't make a difference. Now we do completing the square. So 3, give me my big staple brackets. X, b is minus 10, so half of that is minus 5. So we have x minus 5 squared minus 5 squared. Close those big staple brackets, add a 63 onto the end. And simplify what's inside the bracket. Again, if you're noticing some shortcuts, feel free to use them, but again, be super careful. This comes back up in A-level maths, and students still make mistakes there, okay? So just do it nice and neatly. Now expand the brackets, so we have 3. Again, the staple brackets, not the inside ones. Minus 75 plus 63. So my final answer is 3 x minus 5 squared. Minus 75 plus 63 would be minus 12. And that's it. Hence or otherwise, as a bit of exam technique, just for, thanking you to watch this video, whenever they say hence, right, that means you're just using part A. So we're using this equation to solve this, okay? And again, all you do is take the value in here, flip the sign so it becomes positive, take the value here, and keep it the same. Now, what's even better about this is that inside the bracket, there'll always only just be x. There'll never be 2x or 5x or 10x. So as a result, it literally always is flip this sign, put it here, keep this the same. Always. Super, super lucky. Now here is the other reason you may need to do completing the square in surd form. So, if you're in a non-calculator paper and you have to solve a quadratic and you can't factorize it, it can be very useful to use completing the square. Because either use the quadratic formula and you try and do that by hand, which can be tricky, or you can use completing the square. In some cases, they'll just say by completing the square. So let me show you what this looks like. We do completing the square first. So x, what's b? It's plus 10, so half of that is plus 5. Squared minus 5 squared minus 3 equals 0. I'd always recommend keeping them equals 0 because some students can get confused. So x plus 5 squared minus 25 minus 3 equals 0. And then we're left with x plus 5 squared minus 28 equals 0. Okay, so far we've got a couple of marks. We've got 2 to be exact, okay? And now we want to work out the rest. So how can I solve this using completing the square? Well, in this form, what I can do is move the thing on the end to the right-hand side of the equation. So that gives me x plus 5 squared equals 28. Because again, all I'm doing is adding 28 to both sides. Okay. Now I can square root both sides to get x plus 5 equals, and this is the key part here, plus or minus square root 28. Okay? And then all I do is I subtract 5 to the other side and I'm done. And normally the convention is we put that number first because we want the plus minus to be in the middle. And that's it, that's 5 marks. Pretty good, right? It doesn't say to simplify, so I'm not going to simplify this, if I can anyway. So all you do is you leave it in this exact form and you're done. Okay? Super useful in order to work these out, and again 5 marks is quite a few. Okay, so let's keep going. There are a couple more questions they can ask you. So find the coordinates of the turning point with the curve with the equation this. Okay, this is the same thing that we've been doing previously. Okay, it's just that they've wrapped it all up in one question. So if you notice in the previous questions it was a 3 marker and then a 1 marker. This time it's just one big 4 marker. I'm going to rewrite this so that the x squared's first, just to make it all nice and consistent. And now we're going to do completing the square, but first we need to factorize out this minus 3. Again, it's just x squared, so we can't have minus x squared either. So factorize out the minus 3. And that gives me x squared minus 6x. Why is it minus 6x? Because minus 3 times minus 6 gives me the plus 18. And the plus 9 on the outside. Now we do complete the square. X, what is b? B is minus 6, half of that is minus 3. Squared minus 3 squared. Close the bracket, add 9. Then we have minus 3. X minus 3 squared. Minus 3 squared is 9, so that'll be just minus 9 plus 9. Expand those brackets, we get minus 3 x minus 3 squared plus 27, right? Because minus 3 times 9, times by minus 9, plus 9. So my final answer is minus 3 x minus 3 squared plus 36. So my turning points now are just going to be, you take this and you flip the sign to make it positive 3. Take this, keep the sign the same, 36. 4 marks. Again, it's not too bad. And the good thing about completing the square is because it's considered a very hard topic, they tend to not give you any weird situations. Although the next question is going to disprove what I just said. But for the most part, it's very plain. It's like you have this equation, do completing the square. Or find the turning points, okay? Cool. And lastly, this is probably the hardest question I've ever seen for completing the square. But if you have harder ones, please submit them in. I'll leave my email in the description so you can email it in. A small farmer's field is shown below, so rectangle, and it's classic, right? It has algebra instead of numbers. The area is 27 square meters. Find the perimeter, and you need to give your answer in the form a root 10 minus b. So that is surd form, which means I'm going to be using completing the square, which means I won't be able to factorize. So here's how I approach this kind of question in an exam. I look at what I have, and I think about making equations for that. So they've given me the area. Well, how do I work out the area of a rectangle? I do the width times the length, or other way around, width times length, whatever. So I'm going to write that out. I've got 2x times x plus 6, and that should give me 27 square meters, right? Okay, well, it says find the perimeter. Okay, well, how do I work out the perimeter? Well, what I do is I add the lengths all together. So I need to figure out what the length and the width of this shape is. Well, hang on, I've got an equation here that I can solve. If I expand those brackets, I get 2x squared plus 12x equals 27. That's solvable, right? So let's do it. So move that over to the left-hand side. 2x squared plus 12x minus 27 equals 0. Okay, now how can I solve this? Well, this is where I'd use my head, because you've probably jumped immediately to, I would factorize it. But the thing is, you sometimes can't tell if you can factorize something or not. However, if we look at this is a blessing. They've told us it's in surd form, which means we know we can't factorize it. We either have to use the quadratic formula or completing the square. And because this is a completing the square video, I'm going to do completing the square. Again, factorize out the 2. X squared plus 6x minus 27. Do completing the square on the first bit, so you know this is rinse and repeat. We've done this quite a few times. X plus 3 squared minus 3 squared minus 27. Again, this all equals 0. I'll probably leave out the equals 0 for a little bit, but actually I'll try and write it all down. X plus 3 squared minus 9 minus 27 equals 0. Expand those brackets, we get 2 x plus 3 squared minus 18 minus 27 equals 0. We get 2 x plus 3. I know this is very tedious, right? Okay, this is going to test my mental maths. So minus 9 minus 36. That's minus 45 equals 0. Okay. Now solving this can be not tricky, but it might be a bit involved. We're going to add 45 to both sides. So we're left with 2 x plus 3 squared equals 45. Now, in the last question where we solved, we square rooted straight away. The only time you square root is if the only thing on the side is the thing that's being squared. So we need to move the 2 first. Okay? So let's do x plus 3 squared. And all I'm doing is dividing both sides by 2 to give me 45 over 2. Square root both sides, we get x plus 3 equals, in this case, right, this is what we should think about. It's technically plus minus, right? Plus minus root 45 over 2. So I'm going to write that out just so you guys know that is correct. But let's think about this for a second. Can x be negative if it's the length and width? No. So in other words, it's actually just a plus sign. Because, and imagine this, right? If I said to you right now, could you draw me a line that is negative 2 centimeters long? You can't, right? Lengths have to be positive, so I don't need to worry about this being negative, okay? And then lastly, but certainly not least, that means we have minus 3 plus square root 45 over 2, which we can simplify. So, well, we can't simplify the root 2, but we can simplify the root 45. But I'm going to leave that for now. So what I'm going to do is I'm going to copy that value. I'm going to put it back up here. And we're going to work out now the perimeter. Now, just so you're aware, all of these sides will be the same as the opposites because it's a rectangle, right? If I add all of that up, we get x plus 6 plus 2x plus x plus 6 plus 2x. That gives me, so x, 3x, 4x, 6x. 6x plus 6, that's plus 12 even, my bad, equals minus, sorry, not equals. That's what we have for our perimeter, okay? Now I'm going to sub in this. So let's do it. We get 6 multiplied by minus 3 plus root 45 over 2. Yeah, that's cool. And plus 12 after that. Expand the brackets, we get minus 18 plus 6 root 45 over 2 plus 12. So now I'm going to put this first, so 6 root 45 over 2 minus 6. And if you notice, we have a minus b on the end, so that's quite useful, okay? Now, we need to actually kind of resolve this a little bit. What I'm going to do is I'm going to start solving this root 45 over root 2 thing, right? So we get, where shall I write? I'm going to write root 45 over 2 here. Okay. That would equal, if I break it up into root 9, root 5, so in other words, 3 root 5, right? And that will be over root 2. And that's going to be times by 6. So if I times that by 6, that gives me 18 root 5 over root 2. Understand? So I have here 18 root 5 over root 2 equals minus 6. Now I'm going to rationalize the denominator. Sorry, not equals. Oh, good lord. So I'm going to rationalize the denominator by timesing the top and bottom by root 2. That gives me 18. Root 5 times root 2 becomes root 10, which again, if you look, is in my answer, so I'm quite happy about that. Root 2 times root 2 gives me 2 minus 6. So that gives me 9 root 10 minus 6. So this is A and this is B, which again, it follows all the criteria of the answer. Minus an integer, we have minus an integer, and A is also an integer, and we have the root 10, so that is it. So again, try these questions now if you haven't already, but leave it some time so you forget a little bit, because that's the idea. But hopefully that all makes sense. If there's any parts that you're unsure of, let me know. I know some of you have said that surds are a bit tricky, so I'm hoping this part is okay. But generally speaking, if you have like a square root of a number, you can break it up into 2 other square roots. So 9 times 5 gives me 45, so this is perfectly legitimate. But I will try and go through some surd questions a bit later. But hope that makes sense, and I hope you have a wonderful day.